Welcome to CSAT-GURU. In this session, it is the number system lecture series. In this particular session, we'll discuss the basics of numbers. In that, we'll discuss the classification of numbers, how the numbers are classified. Numbers are classified in various ways. In that, this is one of the way the numbers are classified. First of all, we'll try to understand this classification of the numbers. First, we'll start with counting numbers. Counting numbers. Counting numbers means which we start with 1, 2, 3 means counting 1 pen, 2 pen, 3 pen, 4 pen. Okay. So counting numbers are nothing but 1, 2, 3, 4, 5 and so on infinity. Okay. So these are also known as natural numbers. So first set of numbers are known as natural numbers, which is denoted by n. Natural numbers denoted by n. So n is equal 1, 2, 3, 4 and so on infinity. This is the first set, the basic number set. Okay, also known as counting numbers. If we add, see here 0 is not there. We don't count 0 as a number. You can't say 0 pens, 0 erasers, whatever you want to count. You can't start with 0. So counting numbers are 1, 2, 3, 4, 5 and all. Okay. So if you 0 also included, if 0 also included, that set becomes whole numbers. Okay, that means 0 included 1, 2, 3, 4 with 0. Okay, these are known as whole numbers denoted by W. Denoted by W. So W is nothing but 0, 1, 2, 3, 4, 5 and all. Okay. So until now we didn't use negative numbers. If negative numbers also included, negative numbers means minus 1, minus 2, minus 3, minus 4 and all. So if you add, means if you include the negative numbers also, then that set will become integers. So here, these are all positive numbers. So negative numbers comes in left hand side. So 0, 1, 2, 3, 4 and so on. This is the positive numbers. So this side minus 1, minus 2, minus 3 and so on. So this whole set becomes integers. It is denoted by Z. Okay. So it is the integers. So now, can I write like this? Natural numbers, whatever the natural numbers, already you know that 1, 2, 3, 4 and all these numbers are part of whole numbers. Is it right or not? Yes. That means natural numbers are subset of whole numbers. And all the whole numbers are included in integers. Yes or not? Yes. All whole numbers are part of integers. So n subset to W, W subset to Z. So until now we understood integers. And until now we didn't include the fraction number. So what about fraction numbers? What is fraction? Fraction means writing in the form of P by Q. In the form of P by Q, where Q not equal 0, obviously if Q equals 0, it is not defined. So Q not equal 0. Not only that, P and Q both should be integers. Both should be integers. So if a number is written in the form of P by Q where Q is not equal to 0 and whereas P and Q are both are integers. So that number is known as fraction. Okay. So what about 2? 2 is a fraction or not? Yes, 2 is a fraction also. Means 2 can be written as 2 by 1 where 2 and 1 are both are integers. Are you getting the point? So all natural numbers are also be written as P by Q form. So those are also part of fractions, and 0 also can be written as a fraction. 0 by 1, 0 by 2, anything is 0 only. And all the negative numbers also fractions. That means we are going to include certain extra numbers. So if these another fractions, that means if let us say 3 by 4. 3 by 4 is a fraction, but it is not a natural number. It is not a whole number. It is not even integer also. Why? Integers already 0, 1, 2, 3, 4, and right hand side -1, -2, -3, and so on the left hand side. So these 3 by 4 is a fraction which cannot be written in the set of integers or in the whole numbers and the natural numbers. So if these kind of fractions also included, that time that set will become rational numbers. So now see the tricky part, every integer is a rational number, but all the rational numbers need not to be integers. All it is applicable for everything. See, every natural number is a whole number, but all the whole numbers need not to be natural numbers. Okay, all the whole numbers are integers, but every integer need not to be whole number. In similar way, all integers, all the natural numbers, all the whole numbers are rational numbers, but all the rational numbers need not to be natural numbers or whole numbers or integers. I hope you got the point. So extra fractions are included. So now I can say natural numbers is a subset of whole numbers. Whole numbers is a subset of integers, and is all integers are the subset of q. That is rational numbers. If a number is not written in the form of p by q, where q is not equal to 0 and p, q are integers, those numbers are known as irrational numbers. Irrational numbers are surds. Okay, we'll discuss that part separately, surds and indices. But here you should know the definition, which is irrational number. Irrational number is simply which is not rational number. Okay, which is not rational number means which cannot be written as a p by q form. Okay, let me give an example. See, for example, root 2 is there. Root 4, that is 2. But what about root 2? Root 2 value, you may think that root 2 by 1 I can write as a p by q. No, the condition is this should be integers. Root 2 itself not an integer. So you, even though if you write root 2 by 1, it is not a p by q form. Careful. Okay. So root 2 cannot be written as the what is that? As a fraction. So that's the reason it is known as irrational number. Okay. Later in the class, we'll discuss different types of fractions and different types of decimal numbers and how do we convert. That time I'll elaborate what is exactly, I mean to say, irrational number means which cannot be written as a p by q form. Why it is not written as a p by q form? That also we'll discuss in the further classes. But here you should understand which is not rational number is irrational number. Irrational number is denoted by q dash. Okay, q dash. Dash indicates which is not. Okay. If we add these two together, means all the rational numbers and all the irrational numbers together, that big set is known as the real numbers. So when I say real numbers include all these sets. That means every natural number is a real number, every whole number is a real number, every integer is a real number, even all the rational numbers also real numbers, all the irrational numbers also real numbers. So real numbers include all these numbers. Okay. So real numbers is the, what is that? Combination of all the sets. Okay. This is the fundamental classification of the numbers. Okay. There are other way also we have to classify the numbers that we will discuss further. Okay. So this is the one way of classification. So first we understood natural numbers, which are also known as counting numbers. Then whole numbers, 0 included. Then negative numbers included, that becomes integers, and fractions also included, that becomes rational numbers. So natural number is a subset of whole numbers, whole number is a subset of integers, integer is a subset of rational numbers. Rational number, how will you define the rational number? A number is written in the form of p by q, where q is not equal to 0 and p and q are the integers. If a number is not written in the form of p by q, that is known as the irrational number. And if we add all these numbers, that means rational plus irrational, those set is known as the real numbers. Okay. And which are not real numbers are also known as imaginary numbers, but that part is not our syllabus, means in related to our CSAT syllabus. So I'll confine to real numbers. Okay. So this is the one type of classification which you have to know. This is the first part. Classification of the numbers. So already we discussed what are the natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. Okay. Next, other type of classification that also we'll discuss. The other way of classification of the numbers, other way classification. So here, even numbers and odd numbers. Even numbers and odd numbers. These are the very basic things. I hope many of you know already. These are not new things. I know it, but it's just like a recap. These are the basics, which when you are very clear about these things, then further discussion will be very easy for me to discuss. Okay, that's the reason I want to recap all of these things. Even numbers and odd numbers. What are the even numbers? What are the odd numbers? Okay. So the number which is divisible by 2, or else you can simply write 2, 4, 6, 8, and so on. All these numbers are known as the even numbers. Of course, even 0, -2, -4, even negative numbers also even numbers. So it is defined in integers. Okay, fraction cannot be written as even or odd number. So this classification only for integers. Okay, so the number which is divisible by 2, 2, 4, 6, 8, 0, -1, -2, -4, -6, all. These are all are even numbers. And odd numbers already you know, which is not divisible by 2. So 1, 3, 5, 7, 9, and so on. Here also -1, -3, -5, and so on. Okay. So these are the even and odd numbers. This thing you know very well. But the next part is more important. That is the properties of even and odd numbers. This is very important for you. Means many of the questions are based on this particular concept. What is that? You can choose any even number, and if you add with another even number, you can choose any number. Let us say 4 is an even number and 6 is an even number. If I add these two even numbers, the result always even number. Even plus even, always even number only. That's the one point. Second thing, what about even plus odd number? Any even number plus any odd number. What happens? Let us see. You can choose any even number. Let us say 10 plus 7. The result is 17. 17 is the odd number. Always odd number only. Whenever you add even plus odd or odd plus even, both are same. So even and odd added together, the result is always odd number only. And the other one, that is odd number plus odd number. What happens? Odd number plus odd number. The result is always even number. If you get doubt, you can choose with any 2, 3 examples to confirm yourself. 3 plus 5, 8. 7 plus 9, 16. That is also even number. Odd number plus odd number, always even number. Okay. So I hope you understood this point. The same thing can be elaborated even for further. That means even plus even plus even. Always the result is even. Even plus odd number plus even number. Means one I am choosing as odd number, both are even numbers. Remaining both are even numbers. This time the result is always odd number. See why? Even plus even, even. And already you know even plus odd number, odd number. What about even plus odd? Here is the tricky part. Even is even, odd plus odd will become even. So even plus even becomes even. So once you understand the first thing, then it is easy to elaborate on your own. Okay. Even plus even is even. Even plus odd is odd. Odd plus odd is even. This is the fundamental thing. Based on that, you can elaborate for the four numbers, 5 numbers, whatever it is given. The same pattern will be repeated. Okay. So this is the one part. Next. The next part is with multiplication. What happens with multiplication? Even number into even number. Okay. Any even number is multiplied by other even number. So what happens? Let us say 4 into 6. The answer is 24. Okay. 24 also even number. So even number into even number, the result is also even number. Always. Okay. So what happens? Even number into odd number. You can choose any number. 2 into 3, 6, 4 into 7, 28. That is also even number. Even into odd. Always even only. Even is over. Odd number into odd number. Odd number into odd number. You can choose an example. 5 into 7, 35. Odd number. Odd number into odd number. The result is odd number. Okay. This you need to understand. Even into even number. Even into odd, even. Odd into odd number. If I say even into odd, what's the answer? Even only. In product, one even comes, the entire result will become even only. This is a tricky part. See, let us say even into odd into odd into odd into odd number means all are odd numbers. Up to 100 numbers you write. The result must be even only. Once a even number is there in the multiplication in the product, the resultant is always even only. That's the tricky part. You need to understand. Okay? Then. So this part is over. So even and odd classification. This is the one way of classification of the numbers. Then other way of classification, that is based on the factors. Okay? Factors and multipliers, that we'll discuss separately in LCM and CF. But here only the definition of prime and non-prime, which is composite number, that I will discuss. This is another way of classification of the numbers. Prime number, most important concept in our preparation related to this number system. At least one question, every time we are getting at least one question based on the prime concept only, prime number concept only. Not only for this, even if the question is based on number series, analogy, classification, in the number classification, all are based on, most of the times, based on the prime number concept. Okay, for that I want to elaborate this prime number concept. Okay, so try to understand this prime number concept. First, many of you know basic definition of prime number, which is prime number, which is not prime number. Okay, so a number having exactly two factors, not more than that, not less than that. Okay, that number is known as the prime number. So let us say 2 is a number. What are the factors of 2? That means which number divides 2? 1 divides 2 and 2 also divides 2. So there are two factors which divides 2. Right? Exactly two factors are. So 2 is a prime number. Similarly 3. 3 also. 1 is the factor and 3 also factor. Okay. What about 4? 4 it is divided by 1. 1 is a factor for every number. And 2 divides the 4. And 4 also divides the 4. But here 4 factors are there. As of our definition, exactly 2 factors should be there. So 4 is not a prime number. Okay, so let me write down what are the prime numbers. So this is the important thing. You need to remember at least prime numbers up to 100. How many prime numbers are there up to 100? 25 prime numbers are there. These 25 prime numbers you need to remember. Okay. See, when I say need to remember, it is very important not just to do the calculation. Number series also there. Means number series questions also we do get in CSAT. So there also these prime numbers are very important. If you easily identify the prime number, then the logic will be easy to get it. Otherwise, it is difficult to identify the logic in the number series question. So for that, I insist you to practice to remember up to 100. There are 25 prime numbers. I will give the simple logic to remember. So first of all, there are 25 prime numbers, right? Let me write down. 2, 3, 5, 7, 11, 13, 17, 19. Up to 20, there are 8 prime numbers are there. Okay. 23, 29 means between 20 and 30. If you add 30, this is 53, this is 59. Adding 30. Just a trick to remember. Okay, if you remember directly, it's fine. But even if you get confused, just plus 30. Again, you add plus 30. 53 plus 30, which is 83, is a prime number. And again 30, that is 89, is a prime number. Plus 30 plus 30. In similar way, 31, 37 plus 30, 61, 67. Okay, 91, 97. Okay, here 41, 43, 47. 71, 73, 77. Okay, plus 30 plus 30 plus 30. Okay, but I hope you identified 91 is not a prime number. That also you need to remember. That is the reason I wrote it. Okay, interestingly I wrote it 91. You need to remember 91 is not a prime number. That also you need to remember. Why? This 91 is a product of prime numbers. That is 7 into 13. 7 into 13. That also you need to remember. That's the reason I wrote here. So 91 is not a prime number. And here this also intentionally wrote 77. 77 is not a prime number. That is also a multiple of two prime numbers, 7 into 11. So if you count total 25. Okay, 25 prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, 23, 53, 83, 29, 59, 89, 31, 61. Okay, 91, which is not a prime number, already I told you. 37, 67, 97, 41, 71, 101 also prime number. Okay, but 200 is enough for us. Okay, 43, 73, then 47. 77 is not a prime number. Okay, so why I insist to remember these things? 91 is not a prime number. 77. These are the very important numbers. See, when I go through all the previous year question papers, already I hope many of you have watched that videos. I have a playlist of previous year's question paper discussion. I covered all the questions in one place in one video for each year 2024, 2023. Even I'm going to complete the remaining 2022, 21 to 20. At least 5 years question papers I want to complete. Okay. So once I go through all the previous question papers, I understood that there are certain numbers which are very important to be remembered for the aspirants. So that's the reason I want to mention here based on the previous question papers. When I go through the previous question papers, I understood that these numbers definitely need to be remembered by the aspirant. Generally, that question can be done very easily. Otherwise, student get confused or take lot of time to do the calculation. So those numbers I want to emphasize here to remember, which are related to prime numbers. Okay, which are related to prime numbers. Okay, please make a note and try to remember these numbers I'm going to write based on the previous question pattern. Okay, one important number based on the prime numbers. This already I told you 7 into 11, 77. Wherever you see the 77 number, immediately you have to get an idea. Yes, it's a multiple of 7 and 11. Okay, not only that, even I will show you the previous year's questions. Okay, exactly based on this logic. 3 into 37, 111. 3 into 37, 111. Okay. Wherever you see 111 in the calculation, in the number series, wherever you get that number, immediately you have to recall, yes, it's a multiple of 3 and 37. I will give an example, which is the previous year's question paper. After that, once I complete all the number system concepts, in the last video, I will do all the previous questions related to number system in one go. Okay. So that time also I will repeat all the concepts, but here I will repeat one previous example. 2024 question. This is 222 whole power of 333 plus 333 whole power of 222 is divisible by which of the following numbers? This is exactly 2024 question. Actually, if you see the number, it is not easy to get that which number divides this number. No, it is not that much easy. 2, 3, you can't check it with that way. But with observation, these 2, 2, 2, 3, 3, 3. These two are multiple of 1, 1, 1. That's the logic. These two are multiple of 1, 1, 1. That means whichever the number divides this 1, 1, 1 is your answer. And in the options, it is given 3 and 37. That's the answer. See, that's the reason I emphasize aspirants need to remember at least these important numbers. I'm going through even other numbers. See, I did all the previous year's question papers. I went through all the previous year's question papers. Based on that only, I'm making these videos. So, which are the important concepts student definitely need to remember. Okay. So, in that way, I want to write one more important one. 3 into 5 into 7. See, all are related to prime numbers only. Not normal products. Normal products are infinity possibilities are there. That I am not asking to remember. These are based on the prime numbers. So that's the reason these are important. 1155. Okay, this is also one of the important number to be remembered. And one more interesting number, 1001. 1001 is the multiple of 7, 11, 130. 7 into 11 into 30. Okay. So at least try to remember 77, 111, 1155, 1001. Okay. Even if you try to remember, I will give you few more examples. Okay. Here, the interesting. Already I told you, no, 1120, 1155 and 1001. Remember, 1001 is the multiple of 13, which I mentioned already, 7 into 11 into 13. Not only that, you remember other one. 1003 is the multiple of 70. 1007 is the multiple of 19. See why I am telling this? Most of the students think that 1003 is the prime number. No, it is not the prime number. 1003 is not the prime number. 1001 is not the prime number. 1007 also not the prime number. These are the multiples of, see, there is a pattern. 1000 is the multiple of 13. 1003 is the multiple of 17. 1007 is the multiple of 19. Interestingly, 1009 is the prime number. 1009 is the prime number, and this is the least possible prime number of 4-digit number. So least possible 4-digit prime number is the 1009. It is not 1001, it is not 1003, it is not the 1007. So these are very few things which you need to remember related to prime numbers. Okay. So I hope you to focus on these numbers. Okay. So obviously once you understood the prime number, then which is not the prime number is known as the composite number. So remaining numbers once you write other than these numbers, those are all the composite numbers. One is neither prime nor composite number. Okay. So this way you can now you understood the classification of numbers in terms of even and odd and prime and composite numbers. And here I want to discuss one more concept, that is properties of digits. Okay, properties of digits. See, these are very basic concepts, but very important concept. Okay, these are the deciding factors while you are doing the number system questions. So if you are very clear about these things, the coming concepts will be very comfortable to you. Okay, so face value, place value, and digital rule. Any number, if you write a number, let us say 123. This is the 3-digit number. 3-digit number using 3 digits, which are 1, 2, 3. Okay. So 1, 2, 3. I can write other number also using the same digits. Let us say 3 to 1. See, the digits are same, but the values are different. Is it or not? Why the values are getting different even though the digits are same? Because the number, value of the number, not only based on the digits, it is also based on the place value of the digit. Okay, that is the concept of place value. That means when a digit is placed in a certain position, that value become different. Okay, so that is known as the place value. Face value is same. Means 1 means everywhere it is 1 only. That is the face value. 2 means everywhere 2 only. Okay, means digit. So how many digits are there? Digit means when I use the word digit, 0, 1, 2, 3, 4, 5, 6, 7 up to 9. These are all called digits. Remaining all are numbers. Okay. Digits we have only 10 digits. 0 to 9. Okay. So every digit has its own face value. But depends on where it is located, its place value will become different. So that part we will discuss now. See, for example, let us say 123 only. 123, this 3 value here 3 only, since it is in the ones position. But 2 value is not 2 here. Face value is 2. I am not discussing the face value. Face value means the exact value. I am talking about the place value. So 2 is in the position of 10th. See, this is the ones place, this is the 10th place, this is the hundredth position and 1000. Those assume that you know very well. Okay. So I am not getting into very detail. It becomes very lengthy. And 99% you know that. So 2, the place value is 2 into 10, which is 20. And 1 is in the hundreds position. So the place value of 100, this 1 is 1 into 100, which is equal to 100. So that's the reason, that's the reason 123, if I use the same number, 123 can be written as 100 into 1 plus 2 into 10 plus 3 into 1, which again becomes 123. That you know very well. See, with this concept only, I can write, for example, AB is a number. Don't confuse with A into B. It's not A into B in this context. When I write AB, where A and B are digits, okay, not the variables. A and B are the some digits, okay. So the value of AB, if AB is a 2-digit number, the value, okay, the value of the AB becomes 10A plus B. I hope you understood. Why 10A? Why? A is in the 10th position, 10th place. So 10 into A plus B. In a similar way, if I write ABC is a 3-digit number. So what is the value of ABC? 100A plus 10B plus C. This you need to understand. How the place value will be written. Okay. So this is about the place value. Place value of a given number. Here one more small concept I want to discuss based on the previous questions. Many of the times you will get the question based on a number, a 2-digit number, reversed and add it together. So that time, what's the concept of that question? So here, let us say AB is a number. As already I told you, A is a digit, B is a digit. So value of this is 10A plus B. If the digits are interchanged, means it is written reverse. Okay, that means BA. Now its value is different, right? So this value is 10B plus A. Already you understood? Face value of B is 10 now. Okay. Here interesting concept. Okay. I hope now you understood. If I get the difference of these two numbers, I am using the word difference, not subtracting. Difference also subtraction. But when I use the word difference, that means big minus small. Since I don't know which is the big, which is the small. Okay. So if you subtract this 9 A minus B and this also A minus B. Okay. Difference. Okay. B minus A. Okay. B minus A, that I can write. Sorry. This is 10A minus B plus B minus A. Okay. So 10A minus 10B plus B minus A. Okay. 9A minus 9B, 9A minus B. What I am trying to say, the difference of the numbers when a number is reversed, means interchange of the digits. that difference always multiple of 9. Okay, that is the what is that fundamental statement related to this interchanging digits. I'll give it an example. Let us say 32. You can choose any two digit number. 32. 32 is a number. Reverse it. 23. And find out the difference. What is the difference here? 9 here. Okay? 9 here. 9 is a multiple of 9. Yes, of course. You can choose any number. Let us say 52. Reverse it. 25. What's the difference? 27. Is that 27 is a multiple of 9? Obviously. There's a 9 3 times. Is it or not? So, when you find the difference of the numbers, when number and interchanging number, okay, the difference between the number and its interchanged number, the difference is always multiple of 9. That is one part. The other part, interestingly, this 27 is of course 9 multiple. It is 9 into 3, right? This 3 is nothing but the difference of the digits. 5 and 2. Difference 3. See here 9 is written as 9 to 1, right? This 1 is nothing but difference of 3 and 2. Okay, this is a very interesting logic related to two-digit number and interchanging of the two-digit number. That means the digits are interchanged. Got the point? So this is also very interesting concept. Many a times we are getting the questions based on this concept. So that's the reason I want to discuss this part here itself. Okay. So that's the reason we are discussing properties of digits. Okay. One more small thing I want to discuss. A is a digit. B is another digit. Already you know the digits are 0, 1, 2, 3, 4, 5, 6 up to 9 only. Okay. So my question to you, what is the maximum possible value of this question mark? Maximum possible value. Maximum possible value is only 18. You won't get more than 18. You got the point? Why? Because I mentioned A, B are the digits. So what can be the maximum value of A? 9 only. What can be the maximum value of B? 9 only. Since those are digits. So 9 plus 9, 18. So you won't get the value more than 18. In similar way, if I say A plus B plus C plus D, okay, and all are digits only, not the numbers, not two digit, three digit numbers. Simply A, B, C, D are digits. So what is the maximum possible value of question mark? So it is nothing but 36. I hope now you got the point. So possible maximum value is nothing but 36. Get the point? So these are related to properties of numbers. Sorry, digits. Now the last concept in this video I want to discuss digital root. Digital root also known as the digital sum. This also we'll use very often in the calculation, and certain questions are based on this digital root concept itself. What is this digital root? Digital root is nothing but, let us say 123 is a number. So what are the digits inside the 123? 1, 2, 3. 1 is a digit, 2 is a digit. Sum of all these digits, that is 1 plus 2 plus 3, which is equal to 6. This 6 is known as the digital root of the 123. Okay, repeated sum. See, if you get here two digit number, once again you have to do the sum. I'll show with one more example. Okay, let us say 589. 589 is a number. So digital root means 5 plus 8 plus 9, which is equal to, see, 9 plus 8 is 17, 17 plus 5 is 22. 22. So I want to get digital root. Once again you do, since it's a two digit number. So 2 plus 2, 4. 4 is the digital root of 589. So this concept we'll use in various places. Okay, even in the divisibility rules also I'll use this concept, digital sum or digital root. Okay, these are the basic concepts related to number systems. Okay, number system. And what we discussed in this particular concept, classification of the numbers. In that we discussed natural numbers, whole numbers, integers, rational numbers, irrational numbers, altogether real numbers. Natural numbers is also known as counting numbers starting from 1, 2, 3, 4 and all infinity. 0 is included, whole numbers, negative numbers are included, then integers, fractions also included, rational numbers, which are not rational numbers, irrational numbers, altogether real numbers. Then after we discuss the even odd classification also. The number divisible by 2 is even number. The number not divisible by 2 is the odd number. This classification applicable only integers, not to fractions. Fractions can't written as a even number and odd number. Okay. So even and odd, and certain properties related to even and odd also we discussed. Even into even, the result is even only. Even into odd, also even. Even odd into odd, the result is odd. Okay. Even plus even. Even number plus odd number, odd plus odd number, even number. These are the important points related to even and odd. If even number is multiplied by any number of odd numbers, the result is always even number only. The next classification we discuss prime numbers and composite numbers. Prime numbers, the number having exactly two factors, is known as the prime number. Which are not prime numbers are the composite numbers. Of course, one is not the prime nor the composite numbers. And I insist you to remember at least 25 prime numbers are there up to 100. Those numbers you need to remember: 2, 3, 5, 7, 11, 13, 17, 19, and 23, 53, 83. I mentioned plus 30 plus 30 plus 30. Easy to remember even if you get confused. 23, 29, 29, 59, 89, 31, 61, 91 is not a prime number. That also I insist you to remember as that way only. 91 is not a prime number. That part also you need to remember. Why? 91 is a multiple of two prime factors, that is 7 into 13. In similar way, 37, 67, 97 prime numbers. 41, 71, 101 also prime number. In similar way, 43, 73, 103 also prime number. 47, 77 is not a prime number. Why it is not a prime number? It's a prime factors. Product of prime factors. What is that? 7 into 11. Okay. And 97 is a prime number. So there are 25 prime numbers up to 100. Please try to remember these 25 prime numbers, which are very, very important to be remembered as per your examination point of view. And not only that, I insist you to remember certain numbers as the product of prime numbers, which is 7 into 11. Already I told you 77. 7 into what is that? 13, 91. That also already you know. And few numbers I gave you based on the previous question only. Based on the previous question only, I give these numbers. Otherwise, there are a number of products are there that I am not giving you, which are important to be remembered. Triple one. Triple one equal to what is that? 3 into 37. Okay, 3 into 37. And 3 into 5 into 7 into 13, which is equal to 1155. That also try to remember. And one more thing, 1001. 7 into 11 into 13 is the 1001. And I already told you 1001 is the multiple of 13, 1003 is the multiple of 17, 1007 is the multiple of 19. Why I did mention this thing? Many of the time students confuse that 1001, 1003, 1007 are the prime numbers. These are not the prime numbers. These are the product of prime numbers. And 1009 is the least possible 4-digit prime number. Okay. I hope you understood. Remaining are the composite numbers. And after that, I discussed the uh, properties related to digits, where I mentioned face value. Face value is the normal thing, the exact value of the digit. But place value is different. Depends on where it is located. 100 place or 1000 place or 10th place depends on the place value. So place value, based on the place value only, we can write the value of the number. Okay. AB is a number. So value of that number is 10A plus B, where A is in the position of 10th. So I hope you understood. And digital root. Digital root is nothing but the repeated summation of the digits of the given number. That is known as the digital sum or digital root. So these are the basics of numbers. So this is the first class in our number system series. Okay, I hope you understood this concept. And if you like it, please hit the like button, share it. And if you are not subscribed to our channel, please subscribe to CSAT-GURU. Thank you.